Welcome to Frequency Matters, the RF and microwave update. I'm Pat Hindle, and I'm here with my co-host Gary Lerude. In this episode, we're going to talk about our August military microwave supplements, what you can see right here. We've seen GaN penetrate the military markets a lot, and one application I hadn't heard a lot about until this year was Lockheed Martin's Space Fence radar system. So our cover story takes a look at the system design and also how GaN enabled that system to be realized, as it couldn't have been realized with other materials. And the system is able to track, categorize tens of thousands of satellites and debris that are orbiting the Earth. So it's a very interesting project.
Yeah, it's amazing.
So what else do we have for technical features?
So we have a couple more articles. One of them is a characterization of single-shot large signal phenomena using high-speed oscilloscopes.
Say that 3 times fast.
Basically what that means is how do you record very transient events, single events, with gigahertz frequencies. And it reminds me of in the old days when I used to be working on gas power amplifiers, and we'd blow up devices. And all of a sudden, there's a black crater in the device, and you would never know what happened. Well, the authors of this article describe how, with this instrumentation, you can actually see what happens when a device fails. So it's great for reliability testing. The other article we have is an app node. It's a joint collaboration between Monolithics and Qorvo on a number of models for their GaN devices. So again, in the high power semiconductor regime. And it provides data for designers to use in designing amplifiers. So what do we have for product features this month?
So for product features, we have a rotary joint that transmits HD SDI signals through a blocked off center axis from spinner. We also have VNA extensions through the V, E, and W band, and those are from Sage millimeter wave. And we also had 2- and 4-way power combiners from Fairview Microwave that handle up to 800 watts. So good selection of products there. How about tech briefs?
So in tech briefs we have 3. There's one that's really cool from Mercury Systems. It's a BGA 2 to 18 gigahertz receiver, transceiver, that's actually about an inch, maybe an inch and a half on each side and very thin. And within that 2 to 18 gigahertz transceiver, there's basically 4 channels. It splits into 4 different frequencies, 4 gigahertz frequency bands. And then the 2 upper ones, it does down conversion before detection and conversion to digital. And then the 2 bottom ones, it detects and converts to digital. Wow. So it's amazing what they put in this very small package. The second one is from Holsworth Instrumentation. It's a phase noise analyzer. It has a very low phase noise floor, as you would expect. It covers basically from 10 megahertz up to 6 gigahertz. It also has an option to go up to 20 gigahertz. And the noise floor is 190 dBc, minus 190 dBc per hertz.
And those are really fast, too.
Right.
Yeah.
And it has a MATLAB runtime-based graphic user interface, so it's easy to work with from the user perspective. Kind of on the flip side, we also have a Berkeley Nucleonics signal generator that actually comes in 3 form factors. This one covers 9 kilohertz to either 12, 20, or 26 gigahertz, and it has low phase noise, minus 115 dBc per hertz for a 1 kilohertz offset with a 4 gigahertz signal. So that gives you a sense of it. So 3 interesting tech briefs this month. How about news?
Yeah, so turning to the news, Analog Devices is at it again. They were going to acquire Linear Technology, and shortly after that acquisition, they announced that they're going to acquire the cybersecurity solutions business from Cypress Electronics.
Interesting.
So very interesting. I think this is kind of the last piece that really makes them a full system house. They have networking, they have software, they have security, and a full array of components both in the analog and digital realm. So it really makes them a strong player in the Internet of Things, autonomous automobiles, industrial automation markets. So it's really interesting.
It's interesting, at their earnings release, I listened to the call, and they sort of hinted that they might be moving in this direction, but it certainly wasn't strong enough to think there was an acquisition about to happen.
How about you for the news?
So from my perspective, I think it was interesting at the Intel Developers Conference, they announced that they have a silicon photonics transceiver totally integrated in volume production that they say they're selling to a tier 1 network supplier. And this is interesting because sort of the silicon photonics transceiver has been kind of the holy grail, but the difficulty is, of course, you can't really do a laser in silicon and you have trouble with the detection. So somehow Intel has been able to integrate other technologies with their silicon CMOS and do something that's scalable in terms of manufacturing. And this is an area that's gotten a lot of attention as the data centers become larger and everybody goes to cloud computing. Of course, the data centers no longer can do their interconnects with just copper, so they're moving more and more to optical. And there's a challenge to do that with low cost and very high data rates. So the Intel devices are basically 100 gigabit per second type data rates. We've seen in the last several years companies like MACOM, certainly Qorvo has been in this space for a long time, a lot of different players playing in this space and kind of angling to take advantage of this new emerging market, even startup companies like Keysight Technologies. So it'll be interesting to see with this big announcement from Intel what kind of ripples it has through the rest of the industry.
Yeah, very interesting. So now we have a special guest in the studio. Henri Komrij from Keysight Technologies is here, and he's going to talk with us about terahertz measurements and terahertz challenges. So let's take a look at a clip from that full interview. How do the use and measurement of terahertz impact the wireless markets?
Well, one of the nice things about terahertz is the small wavelengths. And so, for example, at 300 gigahertz, you're talking a millimeter.
Wow.
And as you move higher in frequency, they just get smaller, so that resolution can be particularly valuable, and that helps in imaging applications as well. But in the wireless area, these small wavelengths make for small form factor equipment. So you can imagine small cell, wide bandwidth data networks, maybe in a very densely populated area, where we're moving data across small spaces, but lots of data,
right,
very, very fast. So, that's one of the areas that's helping in wireless communications. And it also impacts some other markets. We talked about imaging, but there's also semiconductors that are clearly going to be part of the wireless market. And when you look at imaging, you're able to, with terahertz applications or terahertz stimulus response and spectroscopy types of applications, you're able to see doping profiles and can see the semiconductor material and whether it's been fabricated properly or not. So all that together will impact the wireless industry tremendously.
So what would be some of the challenges in deploying a system like that?
Oh, in terahertz, it's a little bit of a challenge to generate power,
right,
as you can imagine. So generating power at these frequencies can be difficult, and even generating power at microwave frequencies up to 50 gigahertz is not an inexpensive game. So at terahertz, it's even more challenging. Routing the signals effectively and efficiently can be challenging, and there's lots of different frequency bands. As you go from 100 gigahertz up to 1.5 terahertz, you have different waveguide bands. So connecting the waveguide bands and the flanges and the wavelengths are so small, on the order of microns and millimeters. Any skew in the connection can make a big difference. So those are the major challenges. It's generating that power, and then if you do have the power, of course, there's loss.
Yeah, the propagation loss.
The propagation loss through the atmosphere. That's one of the reasons that terahertz is used in atmospheric research, because it's above the Earth's atmosphere, so you don't have all that water, so it does propagate much better. So it may also be useful, for example, in airplane to satellite communications or satellite to satellite.
Right.
So you can watch the full interview on our website at microwavejournal.com. That was really interesting.
Yeah, Henry's a great guy to talk to.
Right. So I think one more thing to mention before we wrap this up. Labor Day is almost on us, and that means that EDICon is less than a month away. As you well know, you've been working so hard on it. It's kind of snuck up on me. So if you've been thinking about attending EDICon, I'd say you better make your plans pretty quickly. Go to the EDICon USA website. Check out the technical program. A lot of good papers, workshops, panels.
Short courses.
Short courses. You're doing a panel on 5G.
Right.
I'm doing a panel on the connected car. We have a nice reception for delegates, registered delegates, on Tuesday night. Geeka Pelosa will be there on Wednesday night. And then there's a short course on Thursday, RF Basics, I think.
Right.
So check out the website. Of course, the exhibition is full. And you don't have to register basically to see the exhibition, although you should do so you can take advantage of the courses. And we hope to see you in Boston in just a few weeks.
Yes, come on down.
Did I forget anything about EDICon?
No, I think that covers it.
All right. Well, I think that's a wrap for this episode. We want to thank you for watching, and we especially want to thank our sponsor, Mini Circuits. You can check out their line of products at their website, minicircuits.com. Until the next episode, take care.